Object code generation. Let's assume that you have a C program. Then you give the C program to the compiler, and compiler will produce the output in the assembly code. So let's take one code, and that code is given as an input to the compiler. The compiler will generate the assembly code. That assembly code is given as an input to the assembler. Then the assembler will produce the object code. So now that assembly language code will given as an input to the assembler, and the assembler is going to produce the same code that is known as an object code. But when you compile a program, then you are not going to use both the compiler and assembler. You just take the program and give it to the compiler, and the compiler will give you directly the executable code. The compiler is actually combined inside the assembler along with the loader and linker. So all the module kept together in the compiler software itself. So when you are calling GCC, you are actually not just calling the compiler. You are calling the compiler, then assembler, and then linker and loader. So once you call the compiler, then your object code is going to present in the hard disk. Object code contains various parts. Those are header, text segment, data segment, reallocation information, symbol table, debugging information. So in header, the header will say what are the various parts present in this object code, and then it will point out that parts. So header will say where the text segment is going to start and a pointer to it, and where the data segment going to start, and it says where the reallocation information and symbol information. And text segment is nothing but the set of instructions are stored in the text segment, and data segment contains the data you have used. So in relocation information, whenever we try to write a program, we generally use symbol to specify anything. So let us assume you have instruction 1, instruction 2, instruction 3, instruction 4, and so on. Now if you say somewhere go to L4, even if we don't write go to statement in the high level language, the output of compiler will write it. Then that code will be converted into object code, and L4 will be replaced by go to 4. Now go to 4 for the level L4 is going to work fine as long as the program is going to be loaded starting at address number 0. But in most cases, the initial part of the RAM is going to be dedicated to the operating system. Even if it is not dedicated to the operating system, there might be some other process that will already be running at address number 0. So when we are going to load the program into the memory means, if the program has to be loaded in the main memory, it might be loaded anywhere. So let us say 1000 is the new starting address, then all the addresses have to be changed. That is known as reallocation. The original address is known as relocatable address, and the final address which we get after loading the program into the main memory is known as absolute address. So consider here this example. So here this is called as the absolute address, and this is called as the relocatable address. So this is the process of relocation is going on. So relocatable address is nothing but the original address. The original address is called as the relocatable address, and after that, after loading the final address, what you get, that is called as the absolute address. So symbol table, it contains every symbol that you have in your program. For example, int a, b, c, then a, b, c are the symbol. It will show what are the variables that your program contains. And debugging information will help you find how a variable is keeping on changing.